So, welcome back to the scattering matrix concepts. In this session, we will investigate the scattering matrix parameters for elements like the shunt element and the series elements. So, let us begin for the shunt element. We will write the scattering matrix of a shunt element. So, in this case I have a transmission line . So, let us have a shunt element connected on either sides to transmission line. So, the input transmission line has a characteristic impedance Z c, the output transmission line has a characteristic impedance of Z c. This is port 1 and this is port 2. And this is the shunt element J B. So, to find the S11 of this network, we consider port 2 to be matched. So, to find S11, consider port 2 as matched. So, S11, because this is a shunt element, we will discuss this in terms of the admittance Y c minus Y in by Y c plus Y in, and that is equal to So, we just put the values of this input admittance, which is Y c plus J b, looking at towards the right side from port 1. So, the total admittance is Y c due to the transmission line plus the J b. So, it is Y c plus J b and Y c minus Y c plus J b, Y c plus Y c plus J b. That will be equal to minus J b by 2 Y c plus J b. Now, from symmetry we can see S22 will be equal to S11. You can easily see that this network is symmetrical from the port 1 and port 2. So, from symmetry we can write S11 S22 equal to S11. So, S12 can be evaluated by using 18 and 19. So, that can be obtained from 18 and 19, or S12 can be found also from the network by finding V2 minus with port 2 matched, or it can be found by finding V2 minus or find V2 minus with port 2 matched. Now, for a pure shunt element, we must have the input voltage, the total input voltage, which is V plus, V1 plus V1 minus, that will be equal to V2 minus, because port 2 is matched. So, there is no reflected wave from port 2. Now, as V1 minus is S11 V1 plus, we can write V1 plus S11 V1 plus equal to V2 minus. And therefore, we can write V1 plus equal to V2 minus. V1 plus into 1 plus S11 is V2 minus. Now, since V2 minus is S21 V1 plus, since V2 minus is S21 V1 plus, we can write the right hand side as S21 V1 plus. Therefore, S21 is 1 plus S11 and that is equal to S12 reciprocal network. So, 1 plus S11 is 1 minus JB, we have already found out S11, two YC plus JB. And that is given by 2 YC by 2 YC plus JB. And that is equal to S12. Okay. So, this is for the pure shunt element. Next we take the case of a series element. We take the case of a series element and in this case we have this kind of a network. So, the two characteristic impedances of the transmission line on the two sides, they are different. ZC1 is the characteristic impedance of the transmission line on the left hand side, it is Z1, and ZC2 is the characteristic impedance of the transmission line on the right hand side, and that is Z2. And this is the current I1. This is the current I2. The left is port 1 and the right is port 2. So, we know that V1 minus bar, that is the normalized V1 minus, and the normalized V1 plus, they are equal to S11. And that is equal to Z in minus Z1 by Z in plus Z1 with port 2 matched. With port 2 matched. Okay. So, this Z in will be equal to Z2 plus Jx because it is the impedance looking towards the right hand side from this port. So, it is Z2 plus Jx minus Z1 Z2 plus Jx divided by Z2 plus Jx plus Z1. Similarly, if port 1 is matched, we can write V2 minus bar divided by V2 plus bar, that is S22 that is S22, and that is what, if I look at this side, that will be Z1 plus Jx from port 2 looking towards the left, looking towards from this terminal looking towards the left, it will be Z1 plus Jx and minus Z2 divided by Z1 plus Jx plus Z2. Now, so these are the values of S11 and S22. In order to find S21, in order to find out S21, we again consider port 2 is matched. So, we have to say, or we have to assume that port 2 is matched. So, on port 1, what do we have? It is V1 plus V1 minus and that is equal to V1 plus S11 V1 plus. And that is equal to V1 plus one plus S11. Also, I1 is given by Y1 V1 plus minus V1 minus the admittance Y1. So, and that is equal to Y1 V1 plus minus Y1 S11 V1 plus. Okay, so, this is the Y1 is the admittance of the transmission line to the left. So, in port 1. And that is equal to Y1 V1 plus 1 minus S11. Now, we know the current is continuous in a series element. We know that the current is continuous in a series element. So, let us write that down. current is continuous in a series element. And hence, we will have according to the diagram minus I 2 as I 2 minus. So, I 2 is entering, it is entering the network. So, it will be minus of I 2 minus. So, I 2 will be minus of I 2 minus. So, we can write minus of I 2 is I 2 minus, and that will be equal to I 1 because of the continuity of the current, and that will be equal to Y 1 V 1 plus 1 minus S 1 1, which we have already derived. But I 2 minus will also be equal to Y 2 V 2 minus, it will be Y 2 V 2 minus, and therefore, Y 2 V 2 minus will be equal to Y 1 V 1 plus 1 minus S 1 1. We just equate the two, we just equate these two. So, we now get S 2 1 as S 1 2 V 2 minus bar by V 1 plus bar. We will now get that. Now, if I choose a normalized voltage, the normalized voltage is related to the unnormalized voltage V 1 plus, the normalized voltage V 1 plus bar is related to the unnormalized voltage V 1 plus by this relationship, that V 1 plus bar is root of Y 1 times V 1 plus. So, that S 2 1 will be equal to S 1 2 root of Y 2 by root of Y 1. So, root of Y 2 V 2 minus divided by root of Y 1 V 1 plus. That is the definition of S 1 2. Which is coming from here and there. So, this is the definition of S 1 2. So, if I name this as, let us suppose, equation 21, if I name this as equation 21, we will get this is equal to root of y 2 by y 1, root of y 2 by y 1. So, V 2 minus divided by V 1 plus, that is y 1 1 minus S 1 1 by y 2, and that will be equal to S 1 2 equal to S 2 1 equal to root of y 1 by y 2 1 minus S 1 1. Let us make this a bit bigger. And that can also be written as root of Z 2 by Z 1 1 minus S 1 1. Now, we can substitute the value of S 1 1 which we had obtained before. We can substitute from the value of S 1 1 we had obtained before. So, this one, if I name it as equation number 20, if I name this as equation number 20, we can obtain, we can substitute from equation number 20 the value of S 1 1. So, and write from 20 S 1 2 equal to S 2 1 1 minus Z 2 minus Z 1 as J x by plus J x. So, we just substitute from S 1 1 from 20, and that means that leads me to root of Z 2 by Z 1 2 z 1 by z 2 plus z 1 plus j x, and that becomes equal to 2 root z 1 z 2 divided by z 1 plus z 2 plus j x. So, the symmetricity of S11, S12 and S21 appears because of the way the expressions for Z1 and Z2 appear in this equation. So, they are symmetric. So, you see that the S12 and S21 they are symmetric. So, we had used here normalized voltages. We had used normalized voltages. So, if unnormalized values are used or if unnormalized voltages are used, the same expressions will be obtained for S11 and S22, which we had obtained now, but the expressions for S12 and S21 would get changed. In fact, in that case, if unnormalized voltages are used, S11 and S22 will remain unchanged, but S21 will be equal to 2 Z2 by Z1 plus Z2 plus Jx, and S12 will be equal to 2 Z1 divided by Z1 plus Z2 plus Jx. So, if unnormalized voltages are used, let us see how these expressions come. So, in that case, if unnormalized voltages are used, we can find S21 as V2 minus by V1 plus 2 plus is 0 by Y2 Y1 1 minus S11 by Y2 . This we have already derived, and that can be written as Z2 by Z1 1 minus S11, and that is equal to Z2 by Z1. Substitute the value of S11 1 minus Jx minus Z1 by Z2 plus Jx plus Z1. And that is equal to Z2 by Z1 2Z1 Z2 plus Z1 plus Jx, that is equal to 2Z2 by Z1 plus Z2 plus Jx. So, that is S21. In order to find out S12, S12 is nothing but V1 minus by V2 plus unnormalized V1 plus equal to 0 under the condition V1 plus 0. So, then with port 1 matched, port 1 is matched, V2 is V2 plus V2 minus, that is V2 plus S22 V2 plus. That is V2 plus 1 plus S22, and I2 is Y2 V2 plus minus V2 minus, and that is equal to Y2 V2 plus minus Y2 S22 V2 plus Y2 V2 plus one minus S22. Now, since the current is continuous through a series element, since the current is continuous through a series element, we have I2 equal to I1 minus. I2. Therefore, and write Y2 V2 plus 1 minus S22 equal to Y1 V1 minus, and from here I can write down S12 Y2 1 minus S22 divided by Y1 and that is equal to Z1 by Z2 times 1 minus S22 and that is equal to Z 1 by Z 2 1 minus Z 1 plus J x minus Z 2 Z 1 plus J x plus Z 2. And that is equal to Z 1 plus Z 2 Z 1 by Z 2 2 Z 2 by Z 1 plus Z 2 plus G x and then you can cancel these two terms. So, this becomes equal to 2 Z 1 divided by Z 1 plus Z 2 plus G x. So, this completes the derivation of S 12 for the unnormalized voltage case. Okay. So, this ends the section on the concept of scattering matrix. Thank you.